IC-AICE College of Engineering has mustered its rich history and experience in propelling innovation and research across all spheres of technology to organize this event. The numbers speak for themselves. With impressive stats, KDK's Department of Civil Engineering plays a major role in elevating the institution's excellent reputability. The conference is guaranteed to shake the very foundations of civil engineering over the course of 3 days, from the 18th to the 20th of March, 2021. This event would not be possible without the tireless efforts of our esteemed patrons, conference chair, conference co-chairs, and convener. A big thank you to all of them, the organizing committee, speakers, as well as participants, for coming together to make this a truly remarkable and memorable occasion. Having garnered such stellar statistics in their first 2 collaborations, IFERP and KDK have proved that they're a match made in heaven. After having conducted the IC-AICE and IC-APE conferences in 2018, which were astronomical successes for the world of academia, IFERP and KDK College have now come together again, not to replicate their earlier successes but to surpass them. International Conference on Advancements and Innovations in Civil Engineering, March 18th, 19th and 20th, 2021 is finally here. IC-AICE 2021, a major milestone in civil engineering. The 2021 International Conference on Advancements and Innovations in Civil Engineering will raise the bar and pave the way for all future progress in the field. This monumental 3-day event will set the world of civil engineering ablaze with world-class speakers. With its vision of serving society through quality technical education, the KDK College of Engineering has mustered its rich history and experience in propelling innovation and research across all spheres of technology to organize this event. The numbers speak for themselves. With impressive stats, KDK's Department of Civil Engineering plays a major role in elevating the institution's excellent reputability. The conference is guaranteed to shake the very foundations of civil engineering over the course of 3 days, from the 18th to the 20th of March, 2021. This event would not be possible without the tireless efforts of our esteemed patrons, conference chair, conference co-chairs, and convener. A big thank you to all of them, the organizing committee, speakers, as well as participants, for coming together to make this a truly remarkable and memorable occasion.
When it comes to comedy, क्या तुमको पता है
Dhananjay, are you putting up the second one? Sir, we'll start in another 5 minutes of time, sir. Carlos, sir.
I'm sorry?
We'll start in another 5 minutes of time.
Okay.
Yeah.
Just tell me when.
Let the participants join furthermore.
Okay.
In the meantime, we can have a glimpse of the Department of Civil Engineering, KDK College.
Okay.
Madam, shall we begin, sir? Madam?
Yes, sir. Yes, sir. Just 2 minutes, sir. He is doing. Sir, please make Ouchet sir co-host.
रंजन आउटसाइड को co-host कर दो ना सर. धनंजय को co-host कर दो.
Dhananjay sir is not visible in participant list.
धनंजय is not visible. Join नहीं किया है क्या?
Sir, he joined by the name Dhananjay Ouchet.
Yes. Got it.
Oh,
I made it.
Dr. Varghese, this is Gunalan here. So just say.
Oh, very good morning, sir. Very good morning, sir. Very fantastic to see you there in the meeting. Dr. Guna from immediate past president of ASC. We welcome you, sir, today.
Thank you. Thank you.
Yeah.
We'll talk to you soon.
Yeah, we have Sir Carlos also with us today.
Yes, I'm listening.
Whose keynote address is there.
Okay, thank you.
Right, sir.
And I'll join you tomorrow morning too. So
yeah. You can wait for another 5 minutes, sir. 5 minutes or so.
no problem.
Yes,
Thank
sir.
you.
Yeah. Good morning to all dear participants. We are in the second day of International Conference on Advancements and Innovations in Civil Engineering, IC-AICE-2021. Yesterday we had a wonderful time with two keynote speakers, Dr. T.I. Eldo from IIT Bombay and Dr. Philip Ermita from Philippines. Today we too have two distinguished keynote speakers, Carlos Moreira from Mexico and Dr. Mohammad Karkush from University of Baghdad, Iraq. We also had yesterday paper presentations where 36 papers were presented in total, and today expected to present around 40 papers later after these two keynote speak. Now, once again, I take this opportunity to welcome you all for the second day of our international conference. Now I hand over the mic to our moderator, Madam Pallavi Randive. Madam.
Thank you, sir. Good morning, eminent scholars and honored guests. Today is the second day of conference. The knowledge sharing on advancement and innovations have been worthy to mention on day one. Stupendous keynote addresses by Dr. T.I. Eldo and Dr. Philip Ermita and 36 paper presentations were all appreciable. On this second day, I take this privilege to warmly welcome all the professors, faculty members, students, and esteemed audience who have gathered from diverse places across the country for the second day of 3-day online international conference on advancements and innovations in civil engineering. This international conference, IC-AICE-2021, is built with the intent of active and interactive learning organized by KDK College of Engineering, Nagpur, in collaboration with IFERP, ASC-ISWR, IEI, NLC, IST, ICI-NC, and IWWA-NC. The ladder of success is best climbed by stepping on the rungs of opportunity, and we are trying to explore it. A conference is a celebration of knowledge. For sharing the knowledge, today we have renowned personality having ability to mesmerize scholars and people of varied caliber with his intellectual charm all around the globe. He is respected Dr. Carlos Moreira, CEO for Hydraulica Ambiental, Mexico. I heartily welcome Dr. Carlos Moreira by presenting a virtual floral bouquet. We welcome you, sir. I request Professor M.N. Umre to introduce Dr. Carlos Moreira to the gathering.
Thank you, madam. Am I audible?
Yes, sir.
It's my privilege to introduce our keynote speaker, Dr. Carlos Moreira. He did a civil engineering from Universidad Regimontana, Monterrey, Nuevo Leon, Mexico in 1995. He did master's degree in structural engineering from Universidad Autónoma de Nuevo Leon, 2004. He did master's in environmental science from Universidad Autónoma de Nuevo Leon, 2007. He is an active member of American Concrete Institute since 2008. He is having long experience and expertise in trenchless underground utility installation. He is a certified geomembrane lining installation, Bow Ridge, Illinois, USA, 1999. He is having certified in pipe ramming and pipe bursting, Aurora, Illinois, USA, 1996. He is a certified CCTV pipe inspector, Glendale, CA, USA in 1999. At present, he is the CEO of Hydraulica Ambiental, which actively an external consultant for hydraulic solution with the state government of Coahuila. I welcome you, sir, to this conference and hope with your keynote address, all the participants will get enriched with knowledge. Thank you, sir. Thank you, ma'am.
Thank you, sir. I invite Dr. Carlos Moreira for his keynote address on the topic Cast in Place Concrete Pipe. Over to you, Carlos, sir.
Thank you very much. Let me see, I can share my screen.
Yes, sir, you can share, sir.
Okay. There we go. Okay, yeah. For ages, water has been an important part of all of our lives, either in agriculture, transportation, or simply drinking water. The how to control it and make sure it makes it from point A to point B is our main challenge in life. So that's why we have turned to cast in place concrete pipes as a better solution than against what is precast pipe. So what is cast in place concrete pipes? I'm going to give a little background on it. Why CPIP? And we're going to see three different cases in single and in double stage construction methods. These projects were made in Hesperia, California, in Felipe J. Mary Channel, and Ojo de Agua, which is an urban stream inside a main metropole. For my icebreaker today, I'm going to give you a small story, something that happened in Mexico City. One of the professors back in the 1960s, he taught the hydrology class for civil engineering. And the first day of class, he got the students and he told them, I'm going to teach you the basics of fluids. And he said, water or fluids are deaf, dumb, mute, have no handles, and in large quantities are very dangerous. And he sent everybody back to their excuse the class and told them that from there on, this concept was going to have a lot of numbers and additions and subtractions. Basically, we see this is what fluids are. They're an inanimate liquid that in different positions affects our lives. Okay, the first documented cast in place pipe. I know there's Romans and different prices that have done cast in place, but this is the first one that has pictures on it. It was done in the city of Salt Lake City in Utah, in the United States, in the early 1900s. It was a pipe that was used to drain the water that was melted from the snows during the spring season, which affected the main city. As you can tell, they were actually testing. They were as they were going on, they were testing, but the method they were using basically very rudimentary ways to get either the frames and how to pour the concrete. These are some other images of this how this pipe was laid. As you can tell, everything had to be done by hand. There was no heavy equipment to do the digging. For this project, they did use the rebar It will be an equivalent of today's the diameter as a number 2.6 diameter rebar pipe. Obviously, again, everything had to be done by hand. The earth compactation had to be done by hand also, and you can tell the pipe wasn't really perfect circle. This pipe it's still in use to up to date. It has been there for over 100 years and it's still in use, and it also gives the same service. There's actually a main metro train that goes on top of it that was used in the was the 2009 Winter Olympics for this. So they had to do a big study if it makes sure that this pipe was still in good shape to hold up for the weight on top of it. Okay. Next, in the 1960s, the United States also presented what they called the Salt River Project, which was a major project that included dams, reservoirs, channels, and electric power machinery. Mainly, it was used to irrigate. Will take water for irrigation in the states of Arizona, Nevada, and California. Most of this water, when it wasn't controlled, it just drained to the ocean, either in the straight to the Pacific or into the California Gulf. And this was when the what they call the boat for casting place pipes was invented. It was an experiment. It was an experimental stage. People, everything was done by hand, but it was cast in what they called one stage. There were also some other experiments that they did with a bladder, like a big long balloon, and they just filled it with concrete around it. But what was basically more economic was the use of a boat, what they call a boat for casting place. There was also a picture from Arizona, 1963. And the American Concrete Institute, or the ACI, they needed to have a specification for this kind of construction. So they came out with, in the 1960s, with a specification for casting place non-reinforced concrete pipe. This was the first title this method had, because the name says that it doesn't have concrete. These pipes, as they are laid in the ground and cast, the whole pipe works as a with as a, in com, as in compression. That's my word. So it's all work in compression. So there's no tensions. So that means that's why you don't have the need for reinforce. Reinforce nowadays in precast pipe, it's used mainly for transportation, or if the pipes it's used, it's going to be working under pressure. Okay. Now this picture, this is the first casting place pipe that was done in Mexico, in the city of Monterrey, where I'm from, back in 1969. The woman there is my mother, and she's pregnant, and I was used to test the load test in this pipe. Obviously, for those who are in the knowledge of buried utility pipes, these are all the things that affect the pipe itself. And live loads, surface loads, the fill, and it all has to be supported by the stiffness of the pipe. Also, what we're going to talk about in some slides is going to be the width of the trench. That's one of the main things that casting place pipe has as an advantage over a precast. This is a typical cross section of the casting place pipe. Your outside frame is the earth itself, so that also brings savings to your project. This is a typical precast pipe, or any other pipe that you're going to bury underground. You have the typical width. Depending on the countries, you have your different codes, the measurements your pipe has to have for the security of the people that are working on it. When you have casting place pipe, something on my screen. Okay, there was a little note on my screen. I don't know what it is, but I'm sorry. So this is the typical cross section now for a casting place pipe. You actually don't have to dig out this section of your pipe. And it's also a saving from your project. since the outside of this your ground becomes the outside frame of your pipe. This is a typical. Somebody's playing with my screen. It was me. Sorry. Okay, this is a typical installation of a pipe. You need cranes. You need to special equipment to lift and set the pipe inside the trench. It's not the trench either is not that deep, but still you have the width on top. That is very important for the safety of the workers and depending on your country codes. This typical cross section, the strains that your pipe has to be able to withstand. Somebody's playing with my screen. Sorry, I don't know why. Okay, here we go. Again, these are
Carlos,
the
you might
strength.
be on auto forward mode. So on your presentation, it might be on auto forward. Next slide.
Okay, I hope it doesn't do it again.
Okay.
Okay. Well, again, this is the typical the strength. If you don't fill these sections of your pipe, the bottom part, your pipe is not going to be able to withstand the loads, and it's going to start to crack, and you're going to have a leak. Finally, it's going to fail. So the other problem you have with precast is that you have the transportation. You have to save it somewhere in your yard or something before it's going to be installed, or ask the neighbors to if they can use your sidewalk to save the pipe while the machinery is doing a trench. And also you have the loading and unloading, which also makes affects the pipe. That's why I mentioned earlier the rebar. That's especially why you need you have a rebar in your pipes and the precast. I mean, okay. You also the other problems you have is the transportation inside the cities. You have the problem that you have low clearances. You have find your way around these or certain places, and actually, that's more money that goes into your pocket, out of your pocket to get the pipes into your site. Now other things. This in Spanish, but the image has gives a lot of idea of what's going on. Most cities all around the world have the problem with flash floods. Flash floods, it's just a rain, a pour that starts raining, rains 20, 30 minutes, and it's a downpour that's your pipes that are installed don't have the capacity to drain any places. Actually, this happened 2 years ago in our city. You can tell it only rained 30 minutes, and the amount of water that fell, it just created all these flash floods. This is a graph that shows for our city the amount of water, the height of water in millimeters that dates back to 1886 to 1909 to 2009. With the things with words are the names of the hurricanes that have hit our area. We have a return period of 20 years. Every 20 years, we have a big, major hurricane that actually floods our area. But those things are, with the Weather Channel, let us know when these events are going to happen. But again, we have to have the flash flood areas, which is our rains that under 100 millimeters, but with a very short span of time that flood our areas, our cities. Okay, this is from that time graph. We have the average monthly average and the maximum monthly average that we have in our area. As you can tell, our rainy season in average is the month of September, but the month of August has shown worst or more rain than any other month in the year, except May and June. Just as if for your information, we had the Alex hurricane that hit us in 2010. It started raining on May the 31st at around 8 o'clock, and then June the 1st, the rest of the rain fell. So actually, this 246 should be on top of this 309. That was an event with the climate change. Our rain season has moved earlier in the year, and that's happening all around the world. Now, for single stage, what is single stage? Actually, it's the machine we're going to see it right now. It's called a boat. It makes an extrusion of the concrete pipe as it's sliding on the trench. For this project, it was done in Hesperia, California, 83-inch with a double barrel. And this actually, the boat itself, you have the hopper where the concrete's being poured, these windows where the frames are lowered into the machine, and the machine actually slides to your left of the screen. Behind is yesterday's pour, and basically that's, in short words, that's what only happens, or what people will see. This is another view. This is the next frame that's going to be in the window we just saw, and people are just pouring plastic, as the spec says. You have to put a film of clear plastic for the curing purposes of the concrete. This is the front of the machine. This is what we call the dead man, the ones that anchor the machine, so it will be sliding to the front. You can barely see right here the winch. That is actually the one, that the cable winch that's actually making the whole process go on. Now, this is what you see in the inside of the machine. The actual framework is very easy. It's very simple. You can see right here the boats, this circle right here, the arcs, and the aluminum frame. And very, as I mentioned, it's very easy, very simple. And this is the front of the machine. Actually, this yellow arc right here on top, on the outside, that's where the concrete is being poured, and these are the flames that are sliding to the back. We have a rate of about an inch to 2 inches per second. That's the speed of this machine. So actually, we could pour 88 meters per shift. As we were working in an area during this project, neighbors didn't want to know noises from machinery and ready mix trucks going up and down, so we could only work the morning shift. And that's really something that really slowed. We did. It was a 4 mile length, and it took us 3 months to finish this whole project, the double barrel. Now, a double stage. Why double stage? For this project, the J. Mary channel, it was a 3.5 meter diameter pipe, and there's no boat that size. The boat itself, the machine will be too heavy that there won't be a winch strong enough to pull it, to make it slide. So that we had to change the method and start doing it at double stage. Now, this is when we started the project. This is what they showed us. This was the actual channel. There were bridges. There were places where there was no channel. There were places where people. This is what most channels everywhere in the world turn out to be: a dumpster. People just throw their garbage, vegetation, and actually, this was, I guess, nobody told me, but I can tell that it was done in different governments periods. You have different sections. There's this little bridge right here that cuts the actual hydraulic section, and obviously when it rained, water just flowed out of this area. So somebody came up with the idea that was wise to put the channel, just put 3 pipes and cover it, and build a road on top of it. The idea of the government on that period was to make a road, save this area and make a road on top of it. So actually, this is the actual picture. They did it for a while to set the pipes, the channel, and the new road was here. But then, as I mentioned earlier, the flash flood came around. These 3 pipes, they had the capacity for the flow of the water. Water flow went around this wall and down here. It flooded 15 houses. Water came in the window, and the front window, and the furniture and TV and everything came out the other window. Actually, and then the media comes in and made a big issue about this incident. So then I got a phone call. It was the governor of the state of Coahuila. He's he's related to me, and he asked me for help. He said, I have two budgets to solve this problem. He says, I have a budget A, a solution of $2,900 per meter, and I have a budget B with $1,140 per meter. He was asking, why is that such a difference? The difference was that the cheapest one was to do a square section, and the 2,900 was to do drive piles on the side of the channel and build a big slab. So I told him, why not cast in place? So I gave him this price for $550 per meter, and I got a contract. So we started to do 3.5 meter diameter pipe. The concrete that was used there was simple, nothing major, 200 kilograms or 200 megapascals, with no rebar, no additives, no fiber, no ash. You adjust the four basic elements for concrete. This pipe, the outside diameter is 4.2. In case if it was done with a cast in place pipe, not using a precast pipe, the size, the width of the trench would have been 5.6 meters, which actually would have taken part of the side road. Um, Now this is what we were working on. This is a 3.5 meter pipe and the little pipes that we had to change with this method. This was a 1.5 kilometer length pipe, and we did it in the span of 5 months. These were some of the challenges. Part of the trench was in rock, very hard rock, and so we couldn't give the U section. So we had to do everything had to be done by hand. You can see the bottom guides that were used for the concrete as we were pouring it. Yeah, and this pipe did have to since there was an accident with a flash flood. The neighbors were very nervous if the concrete wasn't going to have rebar, so we added rebar just as an additive, so we can save on the concrete, which is actually true. And the separation was only 30 by 30 centimeters, which actually, as I mentioned, it wasn't no use, but it was just to cover the media. This is the pour again. The top frame. Let's see. This is the actual pour. This is the first pour for the top section that we did. This is the section with the final product. The frames were removed, and this is some of the pictures of how the things were going on. As I mentioned, they needed a bigger street for traffic. This is how we feel it, and finally, the channel turned to be a three-lane street. This is another part of the project. This is the channel, as I mentioned. There's a bunch of garbage, vegetation growing in the sides of the walls. This is the same area with the trench already open in the pour. More of it, the pipe, and the fill, and then we finally we ended up with a three-lane street. Now this is the other one that was a little more challenging. It had a bunch of it had a tunnel. It had double barrels. It was a mess. We had to work with running water, which actually was really, really, really challenging. This is, as I mentioned, it's a stream that in the old times it used to be a little stream, but now that the city grew, it now crosses the street, the whole city. It was done also in the city of Saltillo in 2011. This is what we found when we first got there. There were old pipes that were all then made by hand. This was a mix of sewer water with rainwater. As you can tell, the color of the liquid right there. There were slabs, very, very thin slabs. There was a gate or a mesh, a steel mesh that hold the sides of the wall that actually during the time they just rusted and the whole thing just fell apart. Also walls that were just masonry that was just cemented from long time ago. And you can tell the same thing though. The color of the water tells a lot of things, tells a lot of stories. Other things we found that the water had eroded walls, foundations from houses were almost floating houses. Some other sections, houses were next to this little stream, the same thing, the small slab, garbage, and who knows who lives inside. Other homes actually lived inside the riverbed. They were already also illegal people, illegal houses inside the stream. They made their, they were just, they just moved there. It was free. And also, and this is what we got a kick of it when the wife tells the husband that he needs a bigger house. The husband decides to move the bathroom to the outside, and we call it the flying bathroom. So we started. We had to remove everything we could find, rebars, all the old stuff. We actually were, as I was telling you, this little stream was always running water, which was make it really challenging to cast concrete with running water. But we actually did it. One of the other problems was that it was too narrow that we couldn't really get the ready mix trucks inside. So we had to figure out the way to bring it down to our site. Concrete, the slump we use is too dry that it cannot be pumped. So pumping concrete was not an option here for the spec we need for the concrete. So again, the running water, uh, top frame. This is as we were working. One of the advantages we have with casting pipe with double stage is that we can set the frames early in the morning, pour the concrete, and by before after lunch we can remove those frames and set them up again for the next section for the pour. So we can actually pour two times a day. Setting these up frames, it takes us only 45 minutes to set them for the next pour. And actually, the pour that was done in the morning is still too fresh that you cannot walk over it. If you walk over it without a frame, you'll fall. You'll just drop, have an accident there. Okay, so this is the same section. Let me just fly through these pictures, and this is the final product. I don't have the final product. There was actually, this became a park. There was little slides and seesaws, and little kids were running around. Another part of this same area, as you can tell, the vegetation. There's actually a river running through here. You cannot see it, but there's water running. The channels are right here, but the water's running on this side. And we turned with casting place pipe. We turned to this. People now that live there have courts. They can play basketball, soccer, volleyball, and they have lighting. So we made a transformation for this area. Another area was this same thing: vegetation, dead animals, trash, and we turned it again. We made a casting place pipe, and for this project, the actual pipe, the first pipe was the one here on the right, and we connected to this new river. We had the necessity of having a double barrel, 3.5 diameter, with and people would ask, how strong is it? Well, this section right here has 24 hours of that was poured, and we have already concrete mixed pipe truck on top of it. So that's basically how fast we can get strength for it. Another advantage is that we can do a Y section, something that you cannot do with precast pipe. You have to do something else to make connect two pipes. Okay, and this is the final project. Those pipes are under this court, same thing, basketball, soccer, and volleyball, and you can play it all 24 hours if you like. Okay, this is another double barrel. If this had been for our specs, if this has been with a precast pipe, you need to have 60 centimeters on each side of the pipe and in between. So that's a meter, 1.8 meters. That this stretch had to be wider. But now with doing a precast, we can actually, these two pipes share the same wall in this section. This is a 2.1 diameter pipe, and these two pipes right here just share a wall of 30 centimeters. Okay, we had the challenge. We had to do a tunnel to connect these pipes. We had to go via tunnel because the road was that street was too narrow that an excavator could dig but could not. They had enough space to turn and remove the dirt. So we had to do a tunnel. We had to go to the use of TBMs or road headers to start digging a tunnel. So we started hitting this area on both in both ends. We used this machine and the other one, the previous one, to start doing that. One side had clay, the other had very hard rock. This is the inside. And how we got the concrete down there. This pipe was 12 meters deep. So we dug a bunch of pilot holes. You can see them right here. and we poured down self-compacting concrete only with the resistance of 200 kilograms per centimeter square, with no fiber and no ash. People will ask, why didn't we use shotcrete? Because there was a big void. We had to work. It wasn't money efficient. It would be too expensive because we had this void, the pipes right here, and we had this void. If we were gonna do a shotcrete, we had to be filling this by layers, and it will take too long. Right here, you can barely tell that the concrete is just being poured from the surface, and these guys are just setting it in place. This is the final one of the scenes of the final pour of the day. Right here, you can see again the void right here. If you had gone doing it with shotcrete, it would have taken too long and too thick of a layer. When we're done with the pipe, we just through those same potholes, we just poured a slurry to fill that void. And basically, this is all. Any questions before the question? Well, first, I want to thank you guys for inviting me, and I enjoyed and love to give conferences. And when I was invited here, I was also excited to be given a conference for you guys in another part of the world. So, well, thank you again, and I'm open to any questions.
Thank you so much, sir. This is very much one knowledgeable lecture, and definitely the participants have definitely benefited with this lecture and the power of your wisdom. Sir, we'll have now the question answer session. So there are some questions I can see here in chat box. So can we start with the question, sir?
Yes, go ahead, please.
So the first question is from Mr. Raju. How to design 200 MPa concrete mix?
How do we design it? Well, the first we just at the beginning of this projects we just have the ready mix company did the mix, but then we started using the volumetric vehicles. So we did our own mix, and it's actually just we have our own lab. We just do the math basically.
Okay, thank you, sir. So the next question is from Ringshia, sir. Design of concrete for CIP-CP is same as any other concrete design?
Yes, definitely. It's just basically just sand, gravel, water, and cement. That's all. There's things which you can add ash if you like. The one we did for the tunnel that we had to be pouring, we used self-compacting concrete just to make sure that the concrete will flow through a little 4-inch bore we did. So we would make sure that concrete will go all the way down to the tunnel.
Thank you, sir.
I hope that answers him.
Sir, Mr. Raju want to know the code which is used for 200 MPa strength design of concrete.
The code. Well, we actually just go to the ACI, ACI codes for any special code you can have. I mean, the strength you need.
I would like to add something, sir. Here, 200 MPa, it is not 200 MPa, it is 20 MPa, which is equivalent to 200.
Okay.
Yeah, which is equivalent to 20 kg per centimeter square.
Okay, so that's an extra zero then.
Yeah, yeah.
Okay, so probably that was his question he had. Okay.
Sir, Gunaran sir want to know, how do you assure consistency and quality of concrete?
How do I assure it? Well, when we actually, you have to get cylinders. We had cylinders every third truck just to make sure that the mix was right. And basically, what for casting place pipe, what's the main key to this, so it can be efficient and even for the setting, the slump. It has to be very dry concrete. If it's if it's too liquid, too fluid, the concrete won't set, and it will take too long, even to remove the frames.
Okay, sir. Next question is from Mr. Samir. What were the challenges that you faced while concreting?
While what?
We want to know your experience, sir. What were the challenges that you faced while concreting?
Okay, the challenges. Well, one of it was to get the concrete, through those little narrow places. We actually, some parts we had an excavator, just moving the concrete back and forth from the ready mix to where the actual frames were. The other challenges we had was that even though it's a city, there was a lot of demand of concrete from other contractors, and our concrete never made it on time. So that slows or delays your times. I don't know if that's what Keith wanted me to answer, or what other challenges he wanted for us to tell him.
He want to know the challenges, sir. I think it is okay with it.
I think
Okay.
a concrete for casting place concrete pipe is same concrete as any other concrete. So we'll have same challenges for what we have for other concrete. And designing of concrete is a concrete technology. Here it's a pipe technology. So concrete can be designed the way we want by using different admixtures, acids, and all these things. Can be designed, but it's a concrete technology. Am I correct, sir?
Yes, that's correct. No, it's just, like I said, it's a basic, sand, gravel, water, and cement. There's no magic or any other special product we put. Is that in the slump?
Sir, next question is from Walson, sir. What could be maximum diameter of concrete pipe?
Okay, that's a good question. Let's start by the small one. The smallest is about 90 centimeters, under a meter. That depends most of the limit in the going down. It's the actual removal of the frames, and sizes up. You can go probably up to 5 or even more. It depends on your project. If it's going to be for a metro that you're going to have the subway going up and down, you probably have to go to precast or even shotcrete. It also depends, the other thing, what kind of ground you have. Is it a seismic area? There's a bit different, variables that can develop for the size of the pipe. Even how deep you're going to go. Is there a topography? Probably you cannot go that deep because your project demands. So you, instead of doing a big pipe, you can do 2 smaller diameter pipes, like the double barrel.
Thank you, sir. Next question is, what is key admixture of concrete for extreme weather condition and major precautions taken? So the question is from Kavish Patwari.
Okay, for extreme weather. Okay, there's a code
Yes,
from
sir.
the ACI. There's 2 codes from ACI. I don't remember the number. I guess it's a code. Don't quote me on that, but I think it's 309 that talks about hot weather and cold weather, and they'll give you all the specifications. I'm pretty sure. Well, that's where I work from ACI. So I'm pretty sure even in India, or I hope if he's from India. You have your own code for extreme weathers.
Okay. So we'll take 2 more questions here.
Go ahead.
Yes, sir. Sir, the question is from Daksh Kumar. What filtration system you used in the pipe for blockage in future flood?
Okay. The actual pipe, or the water comes into the pipe?
He want to know the filtration system you used in the pipe. Yes, sir.
Okay. Well, there's no filtration, or I don't know if he means the actual length of the pipe. If it's porous or crack. Actually, you do have the pipes itself. It's not for pressure water. This is all gravity. So you will actually have there will be a little leaks here and there, but not as much as the cast in place. You have, precast, you have a possible leak every section you join together with the pipe.
Okay,
I don't know if that answers your question.
Okay, thank you, sir. One Mr. Ritesh Balpande want to know which type of formwork you used It's plywood
Formwork.
or steel? Yes, sir. Formwork.
No, no, the formwork, actually the best is we use it's the the thickness of it's aluminum. All of the
Okay,
frames
aluminium.
it's aluminum, and it's one no it's 3/8 of an inch, and the frame, well, that's the actual what they call it, shell, or the outside, and the other framework is just steel.
Okay, sir. When Mr. Ashik Hussain want to know, his question is general. He want your help regarding the internship done in the abroad, especially in your country.
I didn't
He
get the
want your
question.
guidance. He want
Oh,
your
guidance.
guidance, sir.
Okay.
Yes, sir. How they can do their internship in your country? What is the
Internship.
procedure and all? Yes.
Well, that's not my major. I can tell you a couple schools he can go to, but with us, I don't know. Internship from
Okay,
us.
no problem, sir. Thank you so much. So here we end with our question answer session. I hope the participants are satisfied with the answer given by Dr. Carlos Moreira. And thank you once again, sir, for this wonderful lecture. Thank you so much.
Well, thank you, guys.
Yes, for the participants, the feedback link is provided here in chat box. Please fill that feedback link. It is given there, also displayed here on the screen. You can open that link using this link given here in chat box also, and also it is displayed here on the slide. Please fill the feedback link for each keynote address. Enable e-certificate to you. Please fill it up. Once again, thank you so much, sir. Now, the second keynote address of today is from the renowned speaker, Dr. M.O. Karkush from Iraq. And that will start after 10 minutes. So please join the conference through the same link, sharp at 11:45.
Karkush sir is available.
Okay, so shall we start it now then?
Yeah, Karkush sir.
Yes.
Good morning, Karkush sir.
Good morning.
Yeah. This is Dr. Wilson Varghese, sir. Good morning.
Morning. How are you?
Yeah, very fine, sir.
Thank you.
We just had, sir, Carlos sir's presentation as a keynote speaker for today's first keynote speaker.
Yes.
We graciously welcome you as a second keynote speaker for today.
Okay, I am ready. After 10 minutes, as you
you
say.
Certainly. After we'll begin with after 10 minutes.
Okay.
Right, sir.
Okay.
Okay, sir. So we'll start it at 11:30 then.
Yeah, after 10 minutes, ma'am.
Yes,
okay,
sir.
10
at 11:30.
11:30. Now it is 11:20.
11:20. Yes.
Yeah.
Right.
Okay.
So what is the time there at your place, sir? Karkush, sir?
Time in Iraq?
Yeah, at your place, yeah.
Yeah, it is 8:51.
8:51 in the morning hours or evening?
Yeah, morning.
Morning, okay. Yeah. Good morning to you guys. That's it.
2.5 hour back of India.
Right, sir.
Yeah.
Whereas Carlos, sir, is Thursday, it's night 11:30 there.
Yeah, because
Thursday, they are 12.5 hours behind.
Yeah. It is very early in Mexico, maybe, to wake up and give a lecture. Yeah.
Okay.
Yeah.
And here we have Dr. Guna is also, sir. He is a ASC President 2020. He is there in our meeting at present.
Okay.
Dr. K.N. Gunalan.
Good morning.
Good morning, sir.
How are you? Looking forward to your presentation.
I am good. Thank you very much. Nice to meet you all in this conference, and hope to present my issue after maybe 8 minutes in this conference.
Yes, looking forward to it.
Okay, thank you very much.
So Guna sir's keynote presentation is tomorrow, sir.
Yes.
Tomorrow,
Yes.
yeah, tomorrow this time he would be presenting it.
Same
And we
time.
are
Yeah.
indeed gracious that he has joined today in our keynote presentation, sir.
No problem. Thank you for the invitation. And I wanted to participate and listen to some of those at least. So.
Right, sir. Right, sir.
Yeah.
Yeah. Carlos, sir. Thank you. Thank you very much, Carlos, sir. In case if you are busy, yeah. Thank you.
Yeah, Carlos, I'm sitting in Utah. So I see that you're with Brigham Young University, and I saw that you made a presentation about a pipe in Salt Lake City. So that's in my backyard.
That's correct. That's under Main Street. That's under Main Street where the tracks goes over it.
Yeah, I was with a company called Parsons Brinkerhoff, and we built the tracks.
Okay.
There. So I was able to relate to the location and stuff. So.
Yes, I heard. I saw the advertisement where they were talking about see if this pipe was going to hold the tracks.
Yeah.
Well, I had to go. I wish I could say, but I'm going to have to catch a plane in 3 hours.
Okay, thank you.
I want to thank you guys again, and take care.
Okay, thank you.
So, Dr. Walson, so how many people registered for this webinar?
Sir, in total around 400 are there.
Okay.
Yesterday we had up to 350.
Okay.
And today the number has gone around, had crossed 300. Perhaps they may join back. Now it seems 275.
Yeah. Okay. That's good.
Yeah. Karkus sir, how is the pandemic situation in your place, sir, Baghdad?
The situation is almost.
Is it controlled?
Yeah, it is under control, and there is a quarantine for 2 days in a week, and partial quarantine start from 9 o'clock p.m. Till 5 o'clock a.m. every day.
Okay.
But still no serious cases in my country, and everything I believe under control.
Vaccination processes are begun there, what?
No.
In your place vaccinations?
No.
No, it hasn't begun, sir.
No,
okay.
Just for medical staff, they give a vaccine.
Vaccine, this COVID vaccine, sir. I mean,
mostly Chinese.
Okay.
Yeah, and maybe from Europe also.
Okay.
From UK.
Okay.
Pfizer. And some companies try to manufacture the vaccines from Russia also, because they have license to make that to do that in Iraq.
Okay.
Is there quarantine in India or not?
Yes, sir. The situation is the second, third waves are coming up now. In our place, now I'm sitting in Nagpur. Nagpur is a
Nagpur, yeah.
place. Yeah. You know, it's the Indian places.
Yeah, I was 2 years ago in Bangalore in a
Yeah.
conference in Geoscience Institute with Prof. Shiva Kumar Babu and Prof. Dibanka, also my friends from India.
Okay, right, sir. So
Yeah.
here that the third wave has come. Now the cases are rushing up something like very high now.
Uh-huh.
In our city itself,
Maybe because the population is very high in India.
population it was low some last month. Now it is getting up like anything. Now yesterday itself it was around 4,000 in our city.
Oh. How many population in your city?
In city population is around 35 lakhs.
35
lakhs. 3.5 million, sir.
Yeah.
The
We don't
situation was
we don't have Iraq. All Iraq is about 35 millions, and maybe the cases in Iraq do not exceed 3 to 4,000 every day, but mostly they are recovered. The percentage of death is very few.
yeah, the recovery rate is around 97% as of now.
Yeah.
But now the new strains have come up. Some strains are foreign strains. We call it as foreign strains. Some 3-4 foreign strains have come up identified. They are building up new cases now. But simultaneously, the vaccination process is also going on. The government of India is making up everybody to undergo the vaccination processes. So many have taken vaccination. That process is going on.
Yeah.
But somehow the cases are increasing also.
Okay. Is the vaccines Indian or
Indian?
Yeah,
solely Indian. Indigenous
Good.
vaccines are there. 2 vaccines are there, sir.
Yeah. Are effective these vaccines or not?
Yeah, let us hope more than 35 40 million doses have been already given.
Yeah.
Let us hope that this is making a effective node.
Maybe these vaccines have side effects, as I heard from my
That
friends.
hasn't come up. Well, every vaccine do have some kind of a side effect.
Yeah.
The percentage of side effects the people are suffering with is very meager. So that is not substantial as such. The long run effect will be known little later only. How far effectiveness of it comes. Moreover, new strains are also coming up. And let us hope that this vaccine controls that new strains too.
Dr. Valsain, I'll stick around for a little bit because it's already 12 o'clock.
That's right, sir. Yeah. So, it's a morning hours here. There you have to go for a sleep.
No, not only that, I've got an early morning meeting too. So
is it
I
so?
will listen for a little bit and then I'll excuse myself.
Right, sir. Yeah. That's right, sir. Yeah.
Thank you.
Good. We'll start in. It's 11:30. Madam, can we start?
Yes, sir.
Yeah.
Very warm welcome to all of you once again. We'll proceed with the second keynote address for today by an eminent scholar from Iraq, Dr. M.O. Karkush, Professor, College of Engineering, University of Baghdad, Iraq, on the topic Sustainability Aspects and Deep Remediation of Contaminated Sites. It is indeed a proud moment for us to have with us Dr. M.O. Karkush as a keynote speaker whose academic strength reflects around the globe. So let us welcome a person of distinction and eminence, Dr. M.O. Karkush, by presenting a virtual floral bouquet. Okay,
thank you.
I think sir is sharing here. Okay, we welcome you, sir. We heartily welcome you, sir.
Thank you very much.
Dr. K.N. Gunalan and Dr. R. Inshia is here. We also acknowledge the presence of Dr. K.N. Gunalan, President 2020 ASC, and Dr. R. Inshia, Chairman IC-AICE-2021. Thank you, sir.
Thank you.
May I now request Professor S.R. Satone to introduce Dr. M.O. Karkush to the gathering.
Okay, is my
Thank you,
presentation
ma'am.
appear? Yeah.
Thank you, ma'am.
No, sir,
Dr.
the biodata is being read now. So.
Thank you, ma'am. Dr. Mohabit Obed Karkus did his graduation in civil engineering and post-graduation in structural engineering from University of Babylon, PhD in geotechnical engineering from University of Baghdad. He is an active member of Iraqi Engineering Union, Iraqi Society for Soil Mechanics and Foundation Engineering. At present, Dr. Mohabit is the president of Iraqi Society for Soil Mechanics and Foundation Engineering. He has published more than 50 papers in national and international journals. He is a consultant to the Ministry of Military Industry, Ministry for Municipality and Public Work, Ministry of Education, Ministry of Industry, and Ministry of Interior of Government of Iraq. He has guided 16 research fellows at PG and PhD level. He is associated with around 48 organizations. Few of them are member of Civil Engineering Board, Baghdad University, member, coordinator, and head of exam of Civil Engineering Department of Babylon University, member of team responsible about structural design in Babylon University and Al-Qadisiyah University, member of team responsible about design of school building, World Bank project. At present, Dr. Mohabit Karkus working as a professor at College of Engineering, Baghdad, Iraq, a profound academician, professional, and researcher in the field of structural and technical engineering. I welcome you, sir. Now I hand over the session. To Dr. Mohabit for his keynote address. Thank you.
Thank you very much. I would like to present my presentation this morning. Maybe it is this afternoon in some people, or evening in some people attending this conference. I would like to thank the organizers of the International Conference on Advancement and Innovations in Civil Engineering for inviting me to present my paper in this conference. The title I will talking about is Sustainability Aspects and Deep Remediation of Contaminated Sites. This presentation is a part of PhD thesis defended 2 years ago in Baghdad University about remediation of contaminated sites using sustainable aspects. The structure and or outlines of a presentation can be specified as definition of sustainability, pillars of sustainability, themes of sustainability in geotechnical engineering, multi-criteria analysis, development of framework for sustainability in geotechnical engineering, qualitative assessment of sustainability, quantitative assessment of sustainability, and application of sustainability in geotechnical engineering, deep remediation of contaminated sites, then going for conclusions. Definition of sustainability. Sustainability is a wide range concepts and can be defined by different ways according to the situation that we need to reach, or a condition according to the situation that we need to treat it. Sustainability may be defined as the creation and maintenance of conditions under which humans and nature can exist in productive harmony. That is mean we shall produce a harmony between the activities of human and the nature to be continue safely together and without any side effects on the nature and without any side effects on the human growth especially it is very serious problem that facing all around governments and communities and all around the world, that the rapid growth of communities needs more natural resources, and maybe the environment couldn't withstand such rate of growth in the world. So we need to introduce some of requirements of aspects that we shall follow to go in harmony between the rate of growth in communities and their requirements and the natural resources or the ecological system. Also, we shall deal with resiliency, that is the ability to anticipate, to prepare for, and adapt to change condition and withstand, respond to, and recover rapidly from disruption or extreme events. We shall make a prediction for extreme events such as earthquakes or that may destroy structures, that may destroy communities. So we need to predict these events. Also, we need to predict their magnitudes. We need to make precautions to prevent the damage of such extreme events. From the extreme events that make change in civil engineering and regulations, it is the Chicago fire in 1871. This fire was a conflagration that burned from Sunday, October 8 to early Thursday, Tuesday, October 10 in 1871. The fire killed up to 300 people, destroyed roughly about 9 square kilometers of Chicago, Illinois, and left more than 100,000 residents homeless. This fire was in a field happened by a woman that have a cow and feed their cow, but a fire was flamed and burned her house, and then this fire continues to the nearby fields, orchards, buildings, and destroy about 9 square kilometers from the city. According to this event, the communities, the associations, societies changes the building and fire codes by changing the types of material used in building, by changing the distribution of fire extinguisher stations, also make a factor of safety against fire to control distribution of fire alarms in everywhere to get rapid response and prevent continuous damage of fires. Also, from the extreme events that happened previously and changed the thought and minds of researchers, societies, governments, it is the Santa Barbara earthquake in 1925. This event destroyed a part of a city and pushed the government to publish the first seismic building code to prevent the damage or serious damage effects of seismic activities on the building. Subsequent, this seismic building code developed more and more and more and become one of necessities in the design of building. But still now, in many countries, the effect of seismic is not included in the design. But in the same time, most regions in the world subjected to seismic activities even these countries near from sea. Importance of sustainability. Sustainability, one can take a look for the population growth. We have many problems now in our ecosystem, such as global warming, energy constraints, resources availability, such as metal, cement, oil, etc. One of the important thing that the world population now is about 8 billion, and what expected to be at 2100, the population will be reached to about 11 billion capital. These numbers are expected now after the pandemic of COVID-19, but previously the expected number of population at 2100 was 16 billion. The effect of pandemic make the regression is lower and lower and lower, and they expected to reach 11,000 instead of 16,000. We can imagine if we now 8 billion live in the world, and there are many serious problems such as global warming, energy constraint. How about 16 billion duplication of population and the same resources? It is a big problem to us to live in harmony with the ecosystem if we wish to continue on this global as a human being. So what is the main restriction? It is a restriction the rate of growth in the world. How can we make infrastructure? As civil engineers, we are not deal with the growth rate of population because it is maybe it is social and government legislations that can control such a rate of growth. But as civil engineer, how we can make a sustainable world to be live within? How can make infrastructure construction more sustainable? We can reduce energy consumed in construction and rehabilitation. We can reduce emission emitted in construction and rehabilitation, which is a big problem now, the emission of CO2 and SO4, acidification and CO2. Also reduce consumption of natural resources. We will talk about how we can reduce energy consumed, reduce emission, reduce consumption of natural resources, and increase life cycles of structure. These 4 points are very important to make a sustainable structures, to make a sustainable ecosystem, to make harmony between the natural resources and the number of population to be go safely and effective in this life. Pillars of sustainability that one can deal with. Previously, 3 pillars was defined as sustainability pillars, which are the environment. Environment, as you know, it is consists of 3 components: water, soil, and air. As water, maybe it is not our problem as civil engineers, and air, maybe the quality of air is not our problem also, but we are dealing with the causes of pollution of air, and we are dealing with the causes of pollution of water, and we are dealing with the causes of pollution of soil. So how we can prevent the pollution of air, water, and soil as civil engineers from the projects that we can construct, we can build, we can rehabilitate as civil engineers. The pillars of sustainability are environment. Environment, as I talked, it is depend on the type or quality of water, air, and soil. and how we can live in this environment as a human being, as a plant and vegetation, as trees, also as animals, to be live safely in this ecosystem. Economy, every one of us knows that the economy is a principal concept that we can depend or targeted in the design and construction of a project. So we have to think seriously about the cost and the benefit of each structure we can build up. Also the social effects, the social effects has the social effects depend mainly on the type of community, maybe the type of activity to build in the community, is there neighbor community, and what are services are available in the area of project. Also, the fourth pillar added to sustainability is natural resources. Natural resources, what materials and what quantities of natural resources we can use in construction of a building. That is mean we need also to think about recycling material to be used in construction. Also, we need to think about reducing using materials in construction to provide, but not according, not that is mean not reducing the material used in construction of projects to affect the quality of structure. No, but maybe the design codes, maybe the design procedure, the design method, the design software. There is a difference between codes. There's a difference between methods of design, concepts of design, software. There are a difference. We can, if we have a good knowledge about the codes in the world, the methods of design, the softwares available, we can choose the best to give us safe design with less material in construction. Indicators of sustainability. Everyone, if need to define economy, on which base we can he can define or she can define sustainability. Also, if one need to evaluate social effects or social pillar, on which base can define social effects, economy, environment, natural resources. Every pillar of sustainability needs indicators to be defined and to be measured. According to the measurement and definition of these indicators, we can say this design is sustainable, this material is sustainable, or this project is sustainable. So the indicators or measures are tools used to define the pillars of sustainability. Maybe these tools can be defined qualitatively or may be defined quantitatively. So mostly engineers like quantitative description and measurements rather than qualitative indicators, which maybe do not give the right decision and need highly decision makers with high knowledge to get the right decision, because it is there is wide range, and we can say selection A is more sustainable, selection B maybe, our scenario B maybe is the best, more sustainable, depending on the opinion of the decision maker. So the decision can be changed from different for different scenarios if we are based our selection on a qualitative, not a quantitative. So what are the indicators that can be defined as tools or measurements used to evaluate each pillar of sustainability? There is no specific indicators can be defined each pillar. Actually, there is no specific. So anyone can specify the indicators that need to measure or defined as measurements for each pillar. So I can define the environment as the CO2 emission or SO2 emission as indicators to define the environment, or to define the community. I can make the noise causes to the community is the measurement of social pillar. Maybe also if I need to define the natural resources, I can say about the quantities of materials used in construction a project. The indicators mainly depend on the needs. The needs maybe get agreement between the project owner, the client, the government, the communities. They are in a meeting, put these indicators that must be measured and affect the community, the natural resources, the government, the owner, the contractor, the suppliers, all parties cooperate in construction must be have vote to make the indicators that can be affected each partner in the construction process. So the most common indicators in the environment are global warming, CO2 emission, acidification, SO2 emission, and human health if we are talking about toxicity. The most common indicators in natural resources are quantity and the quality of materials used in construction. The most common indicators in social are noise and vibration caused by construction and affected the community living in the area of construction. The most common indicators in economical are cost-benefit analysis using life cycle analysis. How much I will pay to construct this project and how much I will get back as a benefit from investment of this project. Themes of sustainability in geotechnical engineering. I am, as a geotechnical engineer, will talk about the themes of sustainability in geotechnical engineering. The first one is consumption of resources. That means we need to look about reducing the materials used in construction of foundation. How I can reduce the materials used in construction of foundation. That means I think about changing the type of foundation, changing the type of design method, changing the code used in the design, and the material used in construction, maybe development of industry, producing new materials that can be new techniques also, or new technology can be used in construction instead of using old technology that which need a lot of quantities of natural resources. Also using adequate material to meet the desired requirements, and using alternative types of foundation to meet the design requirements. Also, one of the theme of sustainability in geotechnical engineering is reusing of foundation. If I have a building and this building do not satisfy the economical cost-benefit concept, or it is failed to satisfy the target from the construction, and we need to change using of such building, we should thinking about reusing of foundation. Maybe we can remove the superstructure, but we should think about ability to reuse the foundation by making modification or without making modification if it is satisfactory the design for the new project, to avoid construction of a new foundation. Also, we should thinking about land use and land development. Land use and land development, that is mean we should thinking about using less area to construct a project with satisfying the concepts of design, also using the contaminated sites. The contaminated sites may be the soil from this sites can be used as a construction material or may be used for construction a foundation. Contaminated sites can be contaminated sites or maybe soft clay or expansive soil can be treated to produce good subgrade soil for foundation and for pavement such as in roads construction. So we are should thinking about using contaminated sites. Contaminated sites can be remediated to be good soil for construction, embankment, air dams, also can be used as a foundation for building for structures. Also, we should go and thinking for using soft soil, using expansive soil maybe after treatment by mixing or by sand, stone column or maybe limestone piles may be used in construction of a project. There are many methods for remediation of contaminated sites, maybe geothermal remediation, maybe bioremediation, maybe electrokinetic remediation, also maybe mixing with the material. There are many technologies that can be used for remediation of contaminated soils or for improvement the geotechnical properties of soft or weak soils, or maybe sand dunes also. Also, there are nanotechnology materials also can be used nowadays in improvement of soil and maybe in remediation of soil. Also, we can adopt better risk assessment techniques because the techniques, the assessment of contaminated sites also may be differ from country to country, may be differ from standard to standard. So we can use the efficient technique to evaluate the effect of contamination on the soil or the ecosystem. One of the themes in geotechnical energy, geotechnical engineering, is using energy used in construction. We have materials from sources to be transported to factories, manufactured, such as cement, such as iron, and to be transported to the sites and to be used in the construction, such as gravel, sand, cement, steel, reinforcement. All these materials will need energy to be transported and to be manufactured. So we should thinking about the energy used in these materials, how we can reduce energy by reducing the material used in construction of foundation. Also, these processes of transportation and manufacturing and construction, we need also equipments for construction. All these need energy. So there is a CO2 emission and SO2 emission and maybe toxic compounds will be affect the ecosystem. So we need to reduce these effects by reducing the materials used in construction. Also, the buildings are responsible for considerable amounts of energy in most countries. Construction or projects may be considered the main source of consumption energy in countries. So we are trying to make our buildings consumption energy less by selection of good ventilation system, good lighting system, depending on the nature, not depending on the energy, to get efficient projects with low cost, with low consumption of energy in construction and in occupation. The need to reduce energy consumption and carbon footprint of construction project is essential. What is necessary output to achieve a sustainable project can be defined the sustainable project. We need sustainable architectural design must be sustainable by selection the dimension of the structure, by selection the orientation of the structure, and lighting, ventilation. Then we're going for sustainable structural engineering. That means we are looking for a designer that could use new materials, new codes, new software with low quantities of materials in construction of such projects. Then we're going for sustainable geotechnical
Hello.
engineering. That means we are looking
Bola.
for a better foundation for the project.
Eh?
Then we're going for sustainable mechanical, electrical design, interior design, landscape. Then we are
हे
going
जर
for
संपलं तर याला जितका ओढता येतो ओढून घ्यायचं.
for sustainable construction techniques. Then if we satisfying all these steps, that then we have a sustainable project. Even so, sustainable projects start from design, architectural, structural, then geotechnical, then electrical, mechanical, and construction level will produce a sustainable project. Multi-criteria analysis can be used to evaluate the sustainability of a project. What does mean the multi-criteria analysis for sustainability? That we have the ability to evaluate the sustainability of a project based on social aspects, or we can evaluate the sustainability of a project based on natural resources aspects. Also, we can define the sustainability of a project based on environment aspects or based on economical aspects. So we can produce as a project sustainable from economical view. Also, we can produce a project sustainable from environmental view. Same for natural resources, for social. But if we need a sustainable project that satisfying all the criteria, so we need to use multi-criteria analysis of sustainability. Firstly, we should specify, so if we need to evaluate the sustainability of a project based on the 4 pillars, we need to specify these 4 pillars or 3 pillars or maybe 2 pillars. So we can specify the sustainability of a project if we need to understand or to evaluate the sustainability as a whole. So we need to define the pillars. The pillars may be used social, environment, economy, and natural resources. Then we should go to define the indicators that can be used to evaluate the pillars. How I can evaluate the environment. I will, for example, I will say I will calculate the CO2 emission from materials used in construction based that is mean I have many or several scenarios for design the foundation of a project. So if I have 2 scenarios or 3 scenarios, which one the more sustainable? That is mean the one that give less CO2 emission is more sustainable. If I am looking from for sustainable project from environment view, but if I looking from the cost, the project consumes less cost, it is the more sustainable. If I looking for natural resources, the project consumes less material in construction, is the more sustainable. Social, if the project is less noisy to the community, less vibration to the community, so it is more sustainable. This is mean the sustainability evaluated based on individual pillar. But if we are looking for the whole sustainability, so we need to use multi-criteria. After selection the pillars that we need to evaluate the sustainability of a project, we defined a pillars indicators for each pillar to evaluate. Then thirdly, we give a weight for each pillar. So if I need to hold sustainable, I should give a weight for each pillar. So the natural resources is very important. The summation of the weight is one unity. So if I need, if the natural resources is very important, for example, I will give 0.4 or 0.3 from 1. If social is very important, I will give also 0.3 or 0.4. If environment is not important, may take 0.1. If the social is not important, may take 0.1. So the summation of the weight of 4 pillars or 3 pillars as based on my selection at the beginning of planning for the project will be a unity. Then the lowest score scenario is the more sustainable choice. Which one of the scenarios give me the lowest score? It is more sustainable. The application of this approach require highly experienced people, decision maker, and teamwork, not individual work. Development of a framework for sustainability in geotechnical engineering. The objective of presenting a sustainability framework in geotechnical engineering is to enable designers to achieve the concepts of sustainability, to cover many aspects of sustainability assessment during decision making, and finally to submit more sustainable projects. This framework can be implemented in a quantitatively way, analyzing from multi-criteria analysis and life cycle analysis, or qualitatively way, analyzing from software such as a geotechnical sustainable project, Abrasia routine, GeoSPAR, to reach sustainable project. This software was developed by Holt in 2011 in cooperation with the staff of Arup firm. Step 1, understanding the geotechnical project. Step 2, that is mean I should understand the type of a project, the loss coming from a project, the type of soil, the seismic condition in the site. Everything must be known to me as a geotechnical engineering before starting the sustainable design of foundation or construction of foundation. So it is should be also I must have a wide knowledge about the technologies, about the materials, about the construction methods, how to control a site, how to manage a work in the site. All these things must be in mind to control the work and to produce a sustainable project. Step 2, preparing the necessary data for assessment. Must get data such as magnitude of load, type of load, properties of soil, shear strength, compressibility characteristics, seismic factors of the site. Then going for preparing of the design scenarios. As a geotechnical engineer, like other engineers, must put several scenarios, maybe 2, maybe 3, maybe 4, depending on the ability of the designer and decision maker to put to make a sustainable design and construction of a geotechnical project. Then going for the assessment, step 4, assessment of scenarios. based on the pillars that previously defined, based on the indicators previously defined, and weights previously specified for each pillar of sustainability, and interpretation of results, and step 5, evaluation of sustainable design, and select more sustainable design. Maybe in this step, we are not going for the decision making by selection, a specific scenario for design and construction of project. Maybe one of the selected scenarios need for improvement, so we can change something to meet the requirements of sustainability. If there is a deviation in 1 or 2 or 3 or indicators or pillars, so we can make a modification to meet the requirements of sustainability for indicators or for pillars, one of them. Then going to the qualitative assessment of sustainability. One can evaluate the sustainability of a project based on qualitative. Qualitative is not preferred for engineers, as I said previously at the beginning of this lecture. That is mean the process is wide range, and many people can make different decisions. So it is a very difficult issue if we can base our decision on a qualitative assessment of sustainability. Needs a highly experienced people, and need a big team to make a right decision. So big team and high quality people and highly experienced people, that is mean very costly project, maybe a long time to make a decision. So will make an obstacles or obstacle for starting project in a short period if one wish to make that. So the sustainability of whole construction projects depend entirely on the sustainability of its parts. There are several assessment systems have been developed to assess and embed sustainability into construction and civil engineering industry, but there is still a gap in research of geotechnical engineering. The geotechnical engineers use possible tools to aid geotechnical design. They were immediately labeled as sustainability tools rather than geotechnical tools. SBEAR is a tool software developed for Aruba with aim of making sustainability meaningful to wide range of stakeholders. But this software developed mostly for urban planning, not for geotechnical engineering, but maybe developed or maybe extended to take into consideration the structural aspects, the architectural aspects, the geotechnical aspects. Each one can looking from the view of specialization, such as geotechnical engineering, our target in this research. The methodology is based on a 4-quadrant model that structures the issue of sustainability into framework. This model provides a comprehensive description of sustainability and captures the needs for environmental protection, social equality, economic vitality, and efficient use of natural resources. The actual appraisal is based on the performance of each indicator against a scale of the best and worst cases, and each indicator scenario is aggregated into the relevant sector. The final diagram illustrates the performance of a group of indicators by shading in different colors. The color segment from center of the diagram is the stronger in terms of sustainability. Conversely, the further away from the center is the weaker. Holt in 1910 developed the SPAR to be applicable in geotechnical engineering, so changing the name of the software to be GeoSPAR. Removed some of indicators, define the pillar. Also, in the model prescribed by Holt, remove some of indicators, define the pillars of sustainability, introduce new indicators to define the pillars of sustainability, also changes the limits of indicators between best and worst. Evaluation of sustainability is based on a qualitative aspect, which make this approach complex to be understood and require highly experienced people to make a decision, as said previously. If we are looking for this diagram, it is a circle with 4 quadrants. Each quadrant represents one of the pillars of sustainability: environment, social, economic, and natural resources. Each quadrant is divided into indicators. If I am looking for natural resources, I will see materials used in construction, water used in construction, energy used in construction, land utilization, also wheels hierarchy. So waste hierarchy. If we are looking for environment, we are looking for transport, for design and operation, for ecology and cultural heritage, for water, for land use, for air quality. So as for social impacts, amenity, inclusion, health and welfare, and so on for economic. So this figure shows the 4 pillars of sustainability and shows the indicators that we are selected previously to define each pillar. So we can remove or add indicators. We can remove or add indicators depending on our needs and our situation, our community, our conditions such as availability of natural resources or not, importance of environment, importance of social, importance of economy. So we can add or remove. Also, we can change the limits. The indicators divided into 7 parts. Each indicator is divided into 7 parts. From +3 at the center of the circle to the -3 at the circumference of the circle. So the center of the circle will give green color. That is mean we are very sustainable. Then we can move to the outer circumference of circle with red color. That is mean we are not satisfying the sustainability in this approach. So if we are looking for natural resources, here we get red color. Red color, that is mean it is not sustainable for using material in construction, foundation of a project or a project. So we must think about using another types of materials or changing the design method or changing the quality of the material used in the construction. But when we can, we have seven radial. We have 7 circumferences. At the middle, we have 0. Then we have 3 parts to the center of the circle, going from 0 plus 1 plus 2 plus 3, and going to the outer circumferences of circle minus 1 minus 2 minus 3. So from red color at the outer circumferences to the green color at the center of a circle, there is a definition for sustainability of a project. Based on this circle, resulted from the analysis by GeoSPAR, we can decide if this design and construction of foundation is sustainable or not. This circle will be made for each scenario suggested to design the foundation of a project, such as we say one of the designer or the same designer will be used a raft foundation with improvement the soil below the raft foundation. Another scenario using driven piles, another scenario using board piles, another scenario using screw piles, another scenario using unconnected piles. There are many scenarios can be suggested by the geotechnical designer, and each scenario will be designed firstly, then we will be evaluated based on the selected indicators and selected pillars to evaluate the sustainability of a project. As you see, it is a qualitative evaluation of sustainability and maybe very complicated to make a decision for a simple people. So we recommended highly experienced people and participate of a wide range of community and government and client, contractors, suppliers, contractors to make such a decision, to make a compatibility and produce a real sustainable project. The quantitative assessment of sustainability, the quantitative evaluation of a project sustainability is simple than a qualitative assessment because engineers understanding the language of numbers better than literature. This approach depends on calculation of quantitative of materials used in the project and their effects on the pillars of sustainability. Also, this approach can be easily incorporated with multi-criteria analysis and life cycle analysis. This approach requires from designer to give weights for indicators to evaluate each pillar and weights for each pillars to evaluate the whole sustainability of a project. Also, this approach can be used for individual or whole evaluation of sustainability. The given weights mainly depends on the experience of design team, which will affect significantly on the results of assessment. Application of sustainability in geotechnical engineering, we have a case study for deep remediation of contaminated site. The case study of design, we have a building of 50 by 50 meters on, we need to construct on contaminated sites. The contaminated site is defined as a brownfield because it is contaminated with a percentage of oil products, which may change or affect the geotechnical properties of soil. The allowable load transferred to the building is about 277 and 100 kilonewton. The contaminated zone in the soil mass continues for a depth of 20 meters below natural ground level. The sustainability can be applied in two ways: remediation of contaminated sites using a sustainable technique and selection the most appropriate foundation for the building. The remediation of contaminated soil is important to increase the soil strength and reduce its compressibility. Consequently, will help to reduce cost and dimensions and or type of foundation. Three scenarios are suggested for the design of the project. The first scenario is deep remediation of soil using lime piles. This is the first scenario, will be termed LPR, lime pile remediation. The second scenario is replacement of contaminated soil and construction of raft foundation. So will be termed RSR. And the third scenario is using driven piles and raft foundation. So will be termed DPR. To carry the loading of the building, the three suggested scenarios are designed using traditional geotechnical principle. So we have the three scenarios shown in the table one, line piles with raft footing, replacement of soil with raft footing, driven piles with raft footing. Number of piles after design, 144, area of building to 2500 square meters, and the driven piles, number of driven piles 144, and here number of piles 0 because we use soil replacement instead of using piles to transfer the load deeper than the contaminated sites. So the length of the pile is 25 meters, and the depth of contaminated site is about 20 meters. So we'll transfer the loads to the intact soil below the contaminated zone of soil. But soil replacement selected to be continuous for 8 meters. So the specific geotechnical properties of soil after 8 meters of soil replacement will withstand the load coming from the superstructure. These the three scenarios of foundation suggested for the building 50 by 50 with lime piles and with soil replacement and with driven piles. The key geotechnical properties of soil were obtained from experimental work conducted on soil samples contaminated by oil, unit weight, gamma dry, optimum moisture content, and drain shear strength, in addition to the modulus of elasticity. The lime piles techniques is considered lime piles used for two reasons. The first reason is to remediate the contaminated site, and the second reason is the confining the soil, which means improvement of soil. Improvement of soil resulted in increasing the strength of soil and reduce the compressibility of soil. The impacts of lime piles on the properties of contaminated is attributed to the reaction between the soil minerals and lime that produce cementation compounds such as calcite. Resource, now we're going for the evaluation of the sustainability pillars based on the 4 pillars resources consumption indicator. Consumption resources define the terms of embodied energy are conserved to percentage, and the weight index is applied to confirm the proportional effect of scenarios on the sustainability assessment as listed in table 3. The embodied energy for extracting manufacturing material used in construction of foundation suggested in the three scenarios is considered the main indicator controlling using natural resources in construction. The land contaminated site is considered limited resources, so it is a greater weight of 0.2. The weights per unit of material given for material used in construction are lime and fill material has 0.1 each, cement and steel has 0.2 as manufactured materials, and diesel and water also have 0.1 each. So the summation will be unity. The total score should be 100, and the total weights of resources should be unity. The significant matter in the analysis is the weight given to the resources dependent. So these weights are very important and depend on the experiences of the design and conditions of a project. This table shows the materials used in construction of each of the three suggested scenarios: lime by raft, replacement soil raft, driven by raft, and the weights given for each of the materials. The summation of the weights should be unity, then resources. So we have the score for each type of suggested scenarios. We have, if we make a decision according to the natural resources, the scenario get the lowest score is the more sustainable. So driven pile with raft has the lower score, 25.49, which can be considered the more sustainable than other two scenarios. The second sustainable scenario is lime pile raft, and the third scenario is replacement soil raft. This is evaluation of sustainability based on material consumption. Environment impacts indicators can be evaluated based on the lime used in the remediation and improvement of clay soil contaminated with oil products. Lime is CaO, or quicklime, is formed by heating limestone to decompose the carbonates, and the process will release CO2. The production of lime requires less energy than cement because lime can be burned in temperature 780 to 1340 centigrade, which is lower than the required for cement, about 1700. The mix of lime with water in the soil will produce a hydrate lime, which produces calcium carbonate, resulting in no net emission of CO2. Will take CO2 from atmosphere or water and will produce hydrated lime. Also, the hydrated lime can react with CO2 from oil found in the contaminated soil. The precipitated calcium carbonate in the pores of soil, the precipitated calcite, CaCO3, will make cementation between soil particles and increase its strength and reduce its compressibility. Generally, the assessment of environment impact is based on global warming, acidification, and ecosystem toxicity. Global warming can be assessed based on CO2 emission from material and energy used in the construction of foundation. Acidification can be assessed based on SO2 emission from materials used in construction of foundation. Ecosystem toxicity can be assessed based on human health potential of 1.4 dB. The weight index was adopted for each indicator according to its importance. The weight given for CO2 and SO2 emission is 0.35 and the human health is 0.3, so the total weight is unity. A larger indicator means a less sustainable option, as shown in figure table 4. Table 4 will evaluate the three suggested scenarios: global warming, CO2 emission, acidification, SO2, and ecosystem toxicity, human health. The more sustainable system, also we can see the summation of the total weight is unity here. The more sustainable scenario from environment view is using lime pile raft. The second scenario is using replacement soil raft, and the third scenario is using the driven pile raft. Now we are going for the third pillar of sustainability, is socio-economic. Now we can combine between social pillar and economy pillar. So we can evaluate socio-economic impact indicator. The impact of social is calculated based on noise and vibration effect on the community living in the area of construction, and on the impact of the economy is calculated. Also, the impact of economy will based on the cost benefit of a project. Life cycle will be evaluated for the period life cycle of a project and occupation of such a project and the benefit satisfied from renting such a project for a life cycle such as 25, 30 years, and so on. The indicator of financial return is calculated by assuming that the land after decontamination will be leased at $90 per square meter annually with a discount of 10% annually for the next year. Soil remediation results in interest of 2,047,500 US dollar for renting 2,500 square meters for 10 years. The rental price for next year will be for the first year the rental price is 90 US dollar and 10% decreasing in the annual due to aging of the project. So for the next year will be 81 US dollar for square meter. The cost of soil replacement is assumed of about 220 US dollar per square meter and depth of 8 meters with compact supplement and construction with compaction also in layers. The cost of using line piles technique is assumed about 995 US dollar per square meters. These prices are calculated based on Iraqi markets. And the cost of using driven piles is about $121 per square meter. That is mean I need 144 driven piles of 0.4 times 0.4 cross-sectional area and depth 25 meters. So therefore the cost-benefit ratio is 0.116, 0.268, and 0.148 for the three scenarios as calculated here, and total cost of the project and the cost of each item. If we can evaluate it, the cost-benefit according to the cost of line pile, cost of soil replacement, cost of driven pile. In the absence of noise, damage, and vibration data, it can be assumed as 25, 35, 40% for scenarios because we don't evaluate the noise, damage, and vibration to the community. We assumed these values as a 25, 35, and 40 based on the experience of geotechnical engineer evaluated these. The line pile can cause noise about 25% to the community and vibration, while soil replacement will cause a noise about 35%, and driven pile will cause a noise of 40% for the community. The weight index of socio-economic benefit aspect is assumed 0.6. Now we assume 0.6 for financial and 0.4 for social. Also depends on the experience and situation of a project. The results of the analysis showed that using line pile raft scenario is more financial than using replacement soil raft and driven by raft. So using line piles contributes to sustainable development more than using soil replacement and driven piles from the socio-economic view. Here we have the evaluation of, we give 0.6 for economy and 0.4 for social. So finally we have socio-economic impact indicator. The lowest one is line pile with 23.08, and the second scenario is driven pile raft with 32.68. Multi-criteria analysis. Now we can evaluate the sustainability of a project based on natural resources, based on environment, based on socio-economic, or we can evaluate the whole sustainability of a project based on multi-criteria. That is mean we shall give a weight for each pillar of sustainability. Now we can granted a weight 0.4 for material consumption each, and each of the environment impact and socio-economic will be granted 0.3. So 0.3 for economical social, 0.3 for environmental, and 0.4 for natural resources. The multi-criteria analysis of suggested scenarios showed that 0.4 for natural resources, 0.3 for environment impact, social impact 0.3, the total evaluation or final score for line pile raft 27.52, and the second scenario is driven pile raft 31.5, and the third sustainable scenario is using soil replacement. This is evaluation based on multi-criteria analysis. Conclusion: the following main points can be concluded from the results of this study. Geotechnical engineering is the first step in construction, and it is important increase with increasing the size of the project. Therefore, a reasonable framework should be followed to ensure and applying the concepts of sustainability in geotechnical works of the project. In the suggested framework of sustainability is recommended to use a quantitative analysis rather than using a qualitative analysis. Using multi-criteria analysis incorporated with life cycle analysis is necessary to evaluate the pillars of sustainability. In the suggested framework, it could be evaluated the sustainability of a project based on one of pillars of sustainability or altogether pillars to get comprehensive sustainability for the project. Using lime piles with raft foundation is considered is more sustainable based on environment impact and socio-economical impact. Also, this scenario is considered the more environment sustainable scenario in comparison with the two other suggested scenarios. References used in this presentation. Thank you for listening.
Thank you so much, sir, for your high-spirited and enlightening keynote address. The address has been key-worthy. All the participants must have enjoyed and gained knowledge from it and would apply it in their level of understanding. Thank you once again, sir. One request is for all the guests and participants to turn on their videos so that we can take the virtual picture. I request all the participants and the organizing team members to turn on their videos, please. Thank you so much.
Thank you very much. I am sorry if I take more time than specified for me.
No, sir, it's absolutely fine, sir. Actually, the next session, that is of paper presentation, we are going to start shortly. Within 15 minutes, we'll start it. Once again, I would like to thank Karkush sir for the very informative, knowledgeable lecture. We are grateful for the time and effort you took to share your thoughts and experiences, sir. Thank you so much.
Thank you very much. I am very happy to be with you.
Once again, I would like to acknowledge Dr. Carlos Moreira and Dr. M.O. Karkush, esteemed speaker, for the day 2 of conference, who showered us with their pearls of wisdom and knowledge. We are truly humbled by your presence, sir. Special recognition to all the audience who remained patient throughout. Thanks to all. The feedback link for this keynote session is shared here in chat box. Please fill it up. Yes, it is shared here in chat box. Please fill that. So we'll start the technical paper presentation session 3 and 4 after 10 minutes. So we'll start it at 1 p.m. sharp. So we'll have here the 2 parallel sessions, and to join the session 3 and 4, kindly click on the breakout room option that is displayed on your devices. 2 options are there in breakout room, that is day 2 session 3 and day 2 session 4. The paper list in their respective session is already circulated, so please see where is your presentation, either it is in day 2 session 3 or day 2 session 4, and please join these sessions accordingly. Today we have chair of the session, Dr. Kiran Tajne Asutkar from Government College of Engineering, Nagpur, and Dr. Walson Varghese from KDKC for session 3. Also, we have chair of the session, Dr. U.J. Kahalekar from Government College of Engineering, Aurangabad, and Dr. M.S. Kadu from Ramdev Baba College of Engineering and Management, Nagpur for session 4. So I wish all the best to all the paper presenters, and I hand over the session to the respective moderators, Professor V.D. Vaidya for session 3 and Professor A.D. Shende for session 4. I once again request all the participants to please join the respective sessions from the breakout room. It is displayed here you can see it from your device.
Thank you, Karku sir.
Thank you very much. Thank you. Nice to be with you. Thank you.
It has been a wonderful time that you have given an elaborated presentation on sustainability, and hope that everybody, those who are listening, are benefited of your understanding and let them implement in their course of their learning.
Thank you very much.
Thank you, sir.
Thank you.
I request you to, sir, next time whenever we get an opportunity, please do honor in presenting or be consent to our activities, sir, in presentations or any other mode. May I request all the participants, please join the session 3 or session 4, wherever you are assigned with, so that we can begin with.
Okay. I am sorry, I should leave the meeting because I have.
Yes, sir. Yes, sir. Yes, sir. Yeah. You can leave, sir. Thank you.
Thank you very much. Nice to meet you. Thank you.
Nice to meet you, sir. Thank you.
Good afternoon, sir. Walson, sir. Hello.
Hello.
Can you hear me?
Yeah. I just saw your name.
Yes, sir.
Yeah. प्लीज आप इसमें सेशन 3 में ज्वाइन हो जाइए ना, बिकॉज आप सेशन 3 में है।
तो मैं कहाँ ज्वाइन हुई हूँ अभी?
आप नहीं, आप अभी तो मेन में है।
अच्छा, ये कहाँ
वो
से मिलेगा अभी?
ब्रेकआउट, आपके इसमें ब्रेकआउट रूम दिख रहा होगा ना, सेशन
सर
2।
मैडम का नाम बोल दीजिए, मैं कर देता हूँ यहाँ से।
ये किरण ताजने,
सॉरी,
किरण ताजने मैडम, डॉक्टर किरण ताजने,
डॉक्टर।
किरण ताजने।
ओके, सो व्हिच सेशन? सेशन 3?
सेशन 3।
ओके, डन। नेक्स्ट।
कंपनी उनका वहाँ पे उनकी इंडस्ट्री आना चाहिए, वैसे उनकी भी इच्छा है, उसके लिए उनका प्रयास चालू है। उसके लिए कुछ दिक्कतें यहाँ पे जो है, उसके लिए मैं माननीय पवार साहब को विनती करना है।
हो गया था क्या? मेरी इसमें तो नहीं दिख रहा है। मंत्री साहबों के अधिकारियों के उनसे बातचीत करके इसको थोड़ी गति देने का काम करो, ताकि इंटरनेशनल कंपनी थर्ड सेशन वो लोगों को एक घोषणा की अच्छी करनी हो सकती है, उसके बारे में उसको पूरी जानकारी देने के लिए आया था। उसी प्रकार माननीय मुकेश जी अंबानी के घर के सामने में जो एक जो फाइल है, और दूसरा जो मजदूर जिले की मैडम, मैं अभी वो ज्वाइन सेशन 3 में ज्वाइन करूंगा, तो ये मेन सेशन में मैं नहीं रहूंगा फिर।
और ये जांच में एनआई को राज्य शासन का पूरा सहयोग है, उसमें अच्छी तरीके से जांच होना चाहिए।
हाँ रंजन भाई, मेन सेशन में बहुत लोग दिख रहे हैं ना, उनको शिफ्ट कर दो ना सेशन में। रंजन,
हाँ तर ती स्लाइडवर क्लिक कर
List is displayed here. Participants, please see in which session your name is, and accordingly you have to join that session through the break room. Through the breakout room, you have to join the respective sessions. List is displayed here. Kadu sir, you please join session 2.
Okay.
Breakout room is there, sir. Through that you can join that session.
Where is that?
Is session 4.
Session 4.
Yes, sir. Please open that breakout room. You will see 2 options. So you join that day 2, session 4. Kadu sir?
I'm done. I have done it.
Participants, please join the sessions from breakout room. Please see the displayed list here. Please note down the session and accordingly you have to join your session through the breakout room.
Actually, I listened voice also. हाँ जी बोलिए. No, I'm not. No, I'm not getting it breakout room. ये देखो, right now I am getting. I am observing that who are joined there. That I can see right now. Hello. I am there. Actually, I am observing this Mahendra Umare, Rakshat Band, Anant, Nikhil Bagde. No, session room I am not getting.
Hello. Hello, sir. Hello. Hello, sir.